In this video I'm going to look at the solution to question 9 from the January 2010 Edexcel FP1 paper. The question is on matrix algebra. At the start of the question we're given a matrix and in part A asked to describe the geometrical transformation represented by that matrix. We're then in part B asked to locate the point A which, if transformed by M, ends up at B, which has got given coordinates. Having found A, we're asked to find the length of the line from O to A, where O is the origin. And then moving on to a different part of the question, in part D, simply asked to find the matrix M squared, and in point D, in part E, then asked to use that new matrix M squared to transform the point B to a new point C. Well, looking at part A first of all, then remember that in any matrix we can think about the column giving us I and j positions, I dash and j dash, the new positions of unit vectors after the transformation. So looking at this one here, I and j would be like this, and they've been transformed to new points, 1 over root 2, 1 over root 2 for I. So here this would be I dashed and j dashed at negative 1 over root 2 and 1 over root 2. Now that would perhaps be sufficient, because remember that in your specification then all of the rotations, as this is clearly is a rotation, will be in multiples of 45 degrees. So we can see that this is a rotation of 45 degrees about the origin. A 45-degree rotation about the origin. You don't need to specify anti-clockwise if you're using the notation of positive and negative rotation. So a positive rotation is anti-clockwise and a negative rotation is clockwise. However, if you want to be certain that you're not being ambiguous in your statement, then do mention the fact that this is an anti-clockwise rotation. An alternative method of doing that would be to compare the given matrix, recognizing it as a rotation and comparing it to the general rotation cos theta, sine theta, minus sine theta and cos theta, and then seeing that cos theta and sine theta are both positive, and therefore we're in the first quadrant of the circle, and theta is 45 degrees. The marking for that would simply to give 2 marks for stating the 45-degree rotation, B1 mark, and about the origin. So important that you give that about the origin as your statement for your 2 marks. In the second part of the question then, we're given the fact that the matrix M transforms A onto B, or in other words, writing it out as a matrix transformation, we have that 1 over root 2, 1 over root 2, negative 1 over root 2 and 1 over root 2 multiplied by a vector for A, which we're trying to find, PQ, is equal to the vector that we're given, 3 root 2 and 4 root 2. Again, there are two ways of doing this. The first is to just compare the left-hand side and the right-hand side of this equation, and multiplying out the top row by the vector, we get 1 over root 2 p minus 1 over root 2 q is equal to 3 over root 2, and then the bottom row gives us 1 over root 2 p plus 1 over root 2 q is equal to 4 root 2. So multiplying each of those by root 2 gives p minus q equals 6 for the first one, and p plus q equals 8 for the second one, and therefore adding these gives 2p equals 14, so p equals 7, and subtracting gives us that 2q is equal to 2, and therefore q is equal to 1. As an alternative method, we could use an inverse matrix approach and say that PQ must be equal to M inverse multiplied by 3 root 2, 4 root 2. Because it's a transformation, because the transformation is a rotation then of 45 degrees, the inverse is going to be a rotation of negative 45 degrees, and so it has a matrix 1 over root 2, negative 1 over root 2, 1 over root 2, and 1 over root 2. And if you multiply that by 3 root 2, 4 root 2, you get the answer 7, 1 as before. So p equals 7, q is equal to 1. Well, the mark allocation for this part of the question, 1 mark given for the approach saying that we're multiplying the matrix by pq to give the vector for b. There's then further method mark and accuracy mark for getting to this stage here where we've got the two equations, and finally an accuracy mark for getting the answer p equal to 7 and q equal to 1. With the second method, the marking is similar, M1, A1 for getting to the point where we've got the inverse matrix multiplied by the inverse matrix is M1 A1, and then multiplying it by the vector for B is A1, and finally an A1 mark for getting the P7 and Q is equal to 1. Part C of the question asks us to use the values of P and Q to find the length of OA. So A is the point 7, 1. So the length is simply using Pythagoras' theorem to give us the length of the vector. OA is equal to the square root of 7 squared plus 1 squared, which is root 50. And from 50 we can take out 25 as a perfect square, so this becomes 5 root 2. The marking there was a straightforward M1 and A1. The final part of the question then asks us to find M squared. This is just a case of doing 1 over root 2, 1 over root 2, negative 1 over root 2, and 1 over root 2 multiplied by itself. And the answer to that is 0, 1, negative 1, and 0. There is an alternative to that, which is to say, well, I know that the matrix M represents a 45-degree rotation about the origin, and so M squared will be a 90-degree rotation about the origin, and therefore M squared is equal to the matrix is given there, 0, 1, negative 1, 0. The 90-degree rotation about the origin, think about where your vectors I and j end up. So they end up I pointing upwards at 0, 1, and j dashed along here at negative 1, 0. So that's the 90-degree rotation. Finally then, we're asked to find the coordinates of C, where this matrix M squared takes B, which was 3 root 2 and 4 root 2. So if we simply multiply that out, we get negative 4 root 2 and 3 root 2. So we're asked for the coordinates of C, so we ought to obviously quote it as coordinates negative 4 root 2 and 3 root 2. The mark allocations, there are 2 marks for finding M squared by whichever method, so an M1 and A1 mark, and then 2 marks for completing the multiplication, so a method mark and then A1 mark for giving the coordinates. Okay, that completes this particular video. There are videos for other questions and other modules. You can find those by going to www.furthermaths.org.uk.